we're going to be working with equations which are not in themselves quadratic, but they can be transformed into quadratic equations so that then we can use the techniques for solving quadratic equations with these. And there are going to be a variety of these kinds of equations. So let's take a few examples. Once again, they're not quadratic to start with, but we may be able to make them, transform them into quadratic equations. Solving radicals. Suppose we have the trick with these is to recognize that we can turn. Notice that if we have the square root of p here, by squaring that square root of p, we would end up with the p without the square root. Okay, so it turns out that this term right here is the square of the radical right here. If you can recognize that, you can make a simple substitution. So in this case, let's say, let's let y squared would be the square root of p, the quantity squared, so I would end up with y squared, which is equal to p. So notice that p now is y squared, and the square root of p is the simple y that we started with. Okay, let's substitute these into this equation right here, which is p minus 2 times the square root of p equals 8. P is the y squared minus formed this radical equation into a quadratic equation in terms of the variable that we're using as a substitution for what we have, which is y. So to solve this quadratic equation, we have several techniques. Remember, putting everything on one side, the other side equal to 0, looking at it and then seeing which one of the techniques is going to work in solving this. Remember that the techniques are, we could do it by factoring, we could take the square root formula. So in this case, the things that you might want to use, the techniques might be, see if you can factor. If not, use the quadratic formula. Well, this is a negative, so the signs and the factors would be different. Factors of 8, which give us a difference of 2, well, we know those. Those are 4 and 2. So factoring works in this case. If you can recognize that you can factor, then you can solve the problem. But remember, one side has to be 0 in order for this technique to work. So we said each of the factors equal to 0, y plus 2 equals 0, or negative 2, or y equals 4. But these are solutions in terms of y. Our particular problem was in terms of p, so now we want to express the solutions in terms of p. Remember that the y equals the square root of p, and now we want to know if y equals the number negative 2, what is p equal to? So let's let y be negative 2, and let's solve this little equation for p. Squaring both sides will get rid of the radical here. But just as you did earlier when you worked with equations containing radicals, anytime that you square, you made solutions to the original problem. And so you're going to need to check. Okay? Let's do this other one, y equals 4. Again, the substitution was y equals the square root of p, so that if y is 4, 4 will be equal to the square root of p. Let's square both sides. 4 squared will be equal to p. P then check things. Okay. The original equation, if you remember, is p minus 2 times the square root of p equals 8. So let's check for each time we see a p, we're going to have 4 minus 2 times the square root of 4. Is this equal to 8? And remember, we need to put a question mark somewhere because we're not sure this is going to work at this point. We need to check that out. So we're going to have 4 minus 2 times 2, and what is that? Well, it's not equal to 8. Therefore, this possible solution for P doesn't work, and we need to throw it out. Let's check the other one. What about if P equals 16? Well, we'll substitute it into this equation here, which is the original. So we'll have 16 minus 2 times the square root of 16. And we have 16 minus 2. The square root of 16 is 4. And so on the left-hand side, we have 16 minus 8. And that's certainly is a solution to this particular equation. Okay, so we were able to make this equation, P minus 2 square root of P equals 8, we were able to transform it into a quadratic equation, use the techniques we've learned for solving quadratic equations, and obtained that way were solutions of the equation that we had. In this case, one was